Okay, now, big reaction of enolates. This is the idea of alkylation. And fundamentally, all it is, it's an SN2 reaction. So we're going clear back to organic 1 chemistry in terms of what that means for us. In enolate alkylation, we start off by making an enolate. And do note, this is for enolates. You will not see this done with enols. So, enolates. And that enolate, that good nucleophile, where we have the negative charge next door to the carbonyl, will react with an alkyl halide. Now, since it is an SN2 reaction, it means we can use methyl, we can use primary alkyl halides, we can oftentimes get away with secondary, no, tertiary alkyl halides. There is no way to add a T-butyl group on using enolate chemistry. But for something that can undergo an SN2 reaction, our nucleophilic center is going to break that carbon leaving group bond. The leaving group leaves. We form a carbon-carbon bond, and that's the neat thing about this. We form a new carbon-carbon bond. We have a few of these reactions, and I'll spend some time talking about kind of comparing how do you know when to use what, because our two main categories are organometallic addition and then enolate chemistry. So that will be a comparison we do in a little bit. But for now, we're able to form this new carbon-carbon bond between the alpha carbon, the carbon next door to the carbonyl, and then the carbon that has our leaving group. This opens up lots and lots of opportunities. And I should say, as I've kind of outlined it here, is how they're typically run. We will take a carbonyl, treat it with base to form an enolate. So usually we're going to be using LDA because we want to get 100% enolate. Then we add in our alkyl halide to form the new carbon-carbon bond. We can do lots of things. We'll see we do this mostly with ketones. We can do it with aldehydes. We can do it with esters, but it doesn't necessarily work as well. And that is something we will talk about in another one of these little segments. So for now, lots of ketones, lots of ketone examples. Now, as long as you have alpha protons, you can keep doing enolate alkylation. So if I wanted to add additional alkyl groups, I could. One thing you need to be aware of is if I start off with something that's symmetric, it's easy. Okay, doesn't matter if I deprotonate this side or this side, I get the same enolate. But if I get to a product like this, and I want to do an alkylation, suddenly I have two options. Do I form my enolate here? Do I form my enolate here? Do I do an alkylation here? Do I do an alkylation there? Decisions. And so, but that's great. It means as long as you know where you want to add the next alkyl group, choose the appropriate enolate. So let's take this particular compound. I'm going to move it over here. And let's say I wanted to add a methyl group, but I wanted to add that methyl group over here. So what I want to form is this compound, where if we compare things, all I have is one more carbon on this side compared to what I have here. That actually tells me exactly what I need to do. I need to form an enolate, and I'm going to be using LDA a lot for our enolate formation. So I want to, but the question is now, which enolate do I form? My more substituted thermodynamic, which would be here, or my less substituted kinetic enolate, which would be here. Since I want my additional methyl group off of here, what I need is my kinetic enolate. Now, I'm going to allow you to get away with just saying LDA and then kinetic for this. Oftentimes, if you'll see, it will say LDA minus 78 degrees, aprotic, something like that. Those all go along with it being a kinetic enolate. So, knowing that, there's my kinetic enolate. Now, I just need to add one carbon. So a methyl with a leaving group on it, that will get me to my product. Now again, I am going to come back in a bit and we'll look at examples of trying to decide, how do I figure out what I need to add? Because that is an obvious question associated with this. But for right now, alkylations, symmetric, pretty straightforward. Not symmetric, you need to know where do you want to add a carbon or carbons, and then what enolate do you need, kinetic or thermodynamic.